this is the continuation of section 13.1. And it deals, first of all, with the future value for continuous compounding. And it says here, if a principal amount, if initial deposit of P dollars earns continuously compounded interest at an annual rate R for a period of T years, then the future value A is calculated as follows. A equals P times e to the RT, where e is a special transcendental number, and it's found in your scientific calculators in many cases. And so we use this kind of a expression for a lot of different things. One would be to predict inflated salary levels. And so in 2017, the median salary for occupational therapists was $83,200. Approximately what salary would a person in this field need in 2037, so 20 years later, to maintain purchasing power, assuming the inflation rate were to persist at each of the following levels. So there are two levels. One would be an inflation rate of 2%, which corresponds to the inflation of about 2017. And then the B part would be an inflation rate of 10%, which happened about 39 years ago in 1981. So let's make use of this formula. So for the first part, A, with the future value being the principal, in this case it would be 83,200, to the E, and the rate was 2%, so 0.02 times 20 years. So this is the answer when you evaluate this expression: $124,000 and $124,119.81, or approximately $124,000 per year. For the B part, we have the future value would be 83,200 e to the 0.1 times 20, and when we value that expression, we get this number, $614,769.47, rounded up. Or approximately $615,000. So that's the effect of inflation on people's salaries. Huge difference, of course. For a detailed explanation of the concept of inflation and the Consumer Price Index, I refer you to Chapter 13 on page 740 in the textbook, and also to look at Table 4, which shows the Consumer Price Index, the average one, and the percent changes in Consumer Price Index from year to year. Very informational, and basically tells you how much value your money has lost, or how much more things are, how much more they cost compared to previous years. And to make a reasonable comparison in terms of price increases, here's this formula for a given consumer price product or service subject to average inflation. Prices in 2 different years are related as follows. Price in year A divided by the price in year B is equal to the CPI, Consumer Price Index, in year A divided by the Consumer Price Index for year B. And it sounds very confusing, but what we're looking here is a proportion. In other words, we have a ratio on the left side and a ratio on the right side. And when two ratios are the same, we have what we call a proportion. And typically what's known in a proportion is that we know three of the items and we're looking for the fourth one. And so to apply that, we're going to look at we're going to compare tuition increases to average inflation. And you may be aware of the fact that the average price of tuition and fees at U.S. institutions of higher learning increased quite a bit from $1,626 from 1982 to 1983 academic year to $12,219 for the 2016-2017 academic year. So compare this increased average inflation over the same period. So let's do the numbers on that. So here's how we set up our proportion. Price in the year A, which would in this case be the price in the year 2016-2017. So cost in year 2016-2017 compared to the cost in year 1982-1983. Is equal to the CPI, the Consumer Price Index, CPI, for 2016-2017 divided by the CPI for 1982-1983. And the reason we do it this way is because the academic year goes from the latter half of one year to the earlier half of the next year. And so when we look up the Consumer Price Index for 2016, that would be equal to 240, that's in the table. And we add the one for 2017 and divide by 2, and that's plus 245.1 divided by 2 to get the average. And the same thing for the denominator. So here it is 96.5 plus 99.6 for 1983, 99.6, and all this comes from the table 4 rather, on page 740. That's what the consumer price indices are for the various years. And so this is what we want to know. Since we already know what the cost for 1982 and 1983 is. So then that is our X. This number we want to know, divided by the cost 1982, 1983, and that was $1,626. $1,626. And so these two numbers would be equal to 240. The median would be 242.55, 242.55, and for the denominator it would be 98.05, 98.05. So these numbers are the same. 242.5 divided by 98.05, and so we multiply both sides by 1,626 to eliminate the denominator, and then X equals $4,022. In other words, Remember, we were told that the tuition for the 2016-2017 academic year was $12,219. So $12,219 minus 4,022 divided by 4,022 to compute the percent increase is equal to 2.038 rather. So we can say 2.04. There would be about 204%. So we can say that over the period of, from 1982-83 to 2016-2017, the cost of tuition and fees at institutions of higher learning in the United States increased at a rate of 204% greater than the average CPU, Consumer Price Index. So 204%. So that's by how much the tuition and fees increased, more than you would expect based on the Consumer Price Index. And of course, you can ask yourself, how come? And there are different answers for that. Some are political, so we won't get into that. But anyway, in case you're wondering if there was the imagination that tuition increased a lot more than other things like cars and food and so on, you're absolutely right. They do increase a whole lot more. But 204% more than the Consumer Price Index would indicate. There's an interesting rule that estimates fairly accurately how long it will take for prices to double given an annual inflation rate. It's called the rule of 70. And so the rule of 70 says this. The estimate is that for prices to double, the number of years it takes for prices to double is about 70 divided by the annual inflation rate. So here's the assignment, or the example. Estimate the years to double for an annual inflation rate of 2.3%. So then the years to double equals 70 divided by 2.3 actually. So here we use the percent, and so that would be about 30.43, or about 31 years, given an annual inflation rate that's constant of 2.3%. So in other words, here you need to use a percent sign. So approximately in about 31 years, the prices would double. Of course, that's only an estimate because the annual inflation rate does not remain constant, certainly not for 31 years. That has never been the case. So anyway, it's just an estimate. This is the conclusion of section 13.1.